What's happening, dogs? Mr. Allen here with some polar graphs. For this one, we have r equals 4 minus 2 sine theta. Now, when graphing in polar, I like to identify what type of graph it is first. It's the first step for me because we have a lot of different graphs we can be working with. Cardioids, Limacons, roses, spiral, all sorts of things, okay? Well, because I have a sum or difference here, a subtraction this time, that means it's either a cardioid or a Limacon. Now, because these two numbers are different, it is a Limacon, whereas if they were the same, it'd be a cardioid. Now, the other thing we have to look for with a Limacon, yes, I'm going to be saying it that way throughout the video, I find it fun, is does it have a loop or does it not have a loop? Well, when this number is larger, my A value is larger, it does not have a loop. Okay, if the B value is larger, then it has a loop, right? There's a couple other ways of looking at that. I've seen like A divided by B, if that's greater than or equal to 1, the absolute values of them, then it doesn't have a loop. If A divided by B is less than 1, then it does have a loop. So a couple different iterations there get you the same answer. So this one does not have a loop, okay? And then also, what kind of direction would it be going? Or what's its symmetry? Well, if it's sine, we'll be going up and down with this Limacon, right? It's going to have symmetry over my y-axis there. So let's get to work. For these, I like to use a T-chart. I think that's the easiest way to go about it. I've seen people do patterns and this, that, whatever, little tricks. I like the T-chart. And I'm going to go with my quadrantals. So 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Okay? You don't have to have the 2 pi. I like it to just go all the way around, but whatever. Anywho, so I'm going to plug 0 in for theta. I'm going to evaluate it like I would like in like a rectangular type of situation where I plug in my x, I get my y. It just kind of reversed here on the T-chart. So sine of 0. What's sine of 0? Well, that's 0. So then I just have 4 minus 0 is 4. So r is 4. So for 0, we get 1, 2, 3, 4. Now, pi over 2. Well, sine of pi over 2 is 1. 2 times 1 is 2. So we have 4 minus 2 is then 2. So for pi, pi over 2, we're up at 2. And then for pi, well, sine of pi is 0 once again. So we're going to have that 4. So if I go all the way, boom, I think I'm at 4. 1, 2, 3, 4. Yep. Then 3 pi over 2. Well, that's negative 1. So 4 minus 2 times negative 1 is really like 4 plus 2. That's going to be 6 for this one. So we're going to swing all the way around. We're going to be at 6 for 3 pi over 2. 1, 2, 3, 4, 5, 6. Yep, we're good there. And then 2 pi, again, we're going to be at 0, so we're just back to this guy right here. So it'd be 4 minus 0 is just 4. You will see that repeat of those numbers there, which is, lovely. Anywho, let's try and sketch this thing. So one thing with a Limacon as opposed to a cardioid is that it's not going to come in like sharp like this, right? It's going to come up and kind of like make a little sort of an M kind of a shape to it rather than like a butt, if you will. So let's go ahead and try to do our best here. I'm not always the best at these. Kind of come in. Whoop. Whoa. Kind of missed that one a little bit. But that's decent. You're kind of a heart shape, but again, not sharp right here. It needs to kind of like flow through it like that. There we go. Another key point, when there's no loop, it does not pass through the origin. I have some videos where we do have a loop, okay? And also notice that because this is subtraction here, it's pointing down, right? Whereas if that were addition, I like to do these what ifs sometimes, okay? If that was addition right there, then what I would end up having is the same kind of thing going on, but everything's just going to be reflected, right? So this point would be way up here. This guy would be way down here. These two would actually be in the same spot, and now I'm going to have this. Let's see if we can do a better job this time. Concentration. Kind of, I don't know. Maybe it's better, maybe not, I don't know. But yeah, there we go. So it would be pointing up if that were positive there. And the values would work out that way, right? When I plug in 0 for theta, I'd still get 4. But when I plug in pi over 2 now, it's going to be 4 plus 2, which gives me that 6 right here instead of 2. And when I plug in 3 pi over 2, it's negative, which would then give me that 2. So these two like basically just switch spots, but everything else was still the 4 kind of a thing. Kind of interesting. But anywho, there you go. That's how you would deal with that. If it was negative, it was positive. I like the T-chart because then I don't have to memorize these tricks. Is it opening up, down, this, that, whatever? The T-chart says it all. And that's helpful because we're so used to using T-charts for graphing in any form throughout all of your mathematics. So there we go, guys. Hope you enjoyed it. If you're just starting some polar here, get yourself a jacket. It's a little chilly when you're in the polar coordinates. Have a great day.